Today we're going to learn about a process for solving systems of linear equations called elimination. So elimination, like its kind of name states, when presented a problem like this, if we were to combine both equations or add both equations together, one of the variables would eliminate. Okay, so let's try to do that. So I'm going to kind of add, just like we would do with vertical addition, the top equation to the bottom equation. So x plus 2x gives me 3x. Y minus y, well, that's going to cancel out or eliminate. And then 10 plus 2 is 12. So then I'm left with one variable. So kind of similar to substitution, when you only have one variable, you don't have an x and a y, you either have an x or a y. You can kind of just solve. So let's divide both sides by 3. And we found that x is equal to 4. Okay, so you can kind of see compared to substitution, this process is a little more efficient if your variables form a zero pair, okay? You still do have to go back in at the end of the problem and kind of back solve. So if I were to take this top equation, which is x plus y is equal to 10, I would substitute in a 4 for x. I would find that y is equal to 6. Okay, so then my ordered pair for this system of linear equations is 4, 6. So in the second situation here, I want you to compare it to the first problem, and I want you to notice how in the first problem, when we vertically added or we combined our two equations, the y's formed a zero pair. So what do you do if the y's or the x's, neither of them form a zero pair? Well, let's manipulate our equation so that it does form a zero pair. So I'm going to multiply the bottom equation by -1, and I'm going to rewrite it over here to the right. It's really important that you guys rewrite just so we stay organized. So I'm going to distribute this -1. Whatever you do to one side of the equation, you got to do to the other. So we got to multiply this -1 by the x, by the positive 3y to form -3y, and by the positive 12 to form a -12. Okay, and we didn't touch the top equation, but we want to end up vertically adding these, so I'm just going to rewrite. So once it's rewritten, you can kind of just notice that if we combine these, the x's will form a zero pair and they will eliminate. So I'm left with -y, I'm vertically adding, so 2y plus a -3y is equal to -3. And I don't want that y to be negative, so I'm going to divide both sides by a -1. And I end up with y is equal to 3. Okay, so then once I know what y is, I can kind of easily take my top or bottom equation and I can substitute in, instead of y, I want to write a 3 in for that y. So it's going to become x plus 2 times 3 is equal to 9. So then I have x plus 6 is equal to 9. So I think x is going to end up being 3. Okay, so now that I know what x and y are, I've got my ordered pair, 3, 3. So the last situation we might see is kind of like number 3 here, where we have to manipulate, just like we did in number 2, our equations so that they do form a zero pair and they will eliminate, but we have to manipulate both the top and the bottom equation, okay? So I want you guys to notice that on the top equation, we have a 2x, and on the bottom equation we have a 3x, so they don't have neither one is a GCF or a common factor of the other one. So we kind of do have to multiply both the top and the bottom equation. A trick that I've kind of picked up over the years is you can always multiply the top equation by the coefficient in front of the variable you want to eliminate. You can always multiply the bottom equation by the coefficient in front of the variable you want to eliminate. The only tricky part is you have to make one of those end up being negative, so I'm going to choose the bottom equation. Okay, so let's distribute, then rewrite. So I'm going to distribute the 3 to the 2x, the 4y, and the 8. Remember, you got to do it to every single thing in that equation. So I'm going to end up with a 6x plus a 12y is equal to 24 for my top equation. And then same thing for the bottom one. I'm distributing a -2 so that this 3x becomes a -6x, and that's what we want because 6x and -6x form a zero pair. So the -2y times -y gives me a positive 2y. Two negatives multiplied give me a positive. And that equals positive 4, okay? So then once I combine these, my 6x and my -6x, well, my -6x, those are a zero pair, so those eliminate. And I've got 12y plus 2y, that gives me 14y is equal to 28. Divide both sides by 14, and we've got y is equal to 2, okay? And the last step here, we've got to back solve. So choose either the top or the bottom equation. I'm going to choose the bottom one. So I've got 3x minus y is equal to -2. I'm going to substitute in a 2 for that y. So I'm going to rewrite 3x minus 2 is equal to -2. I'm going to add 2 to both sides, isolate my variable. I've got 3x is equal to 0. So x is going to be 0 for this one. So my ordered pair for number 3 is going to be 0, 2. So in each situation, we used elimination to create a 0 pair once we combine these equations to find one of our coordinates, either x or y, for the point in which these systems intersect. Okay, and then kind of using that back solving process to find the other coordinate. And if you use this process, it will work every time for you. So there wouldn't be a time where elimination wouldn't work. Just on occasion here, you might have some numbers that would be, some equations that would be better suited for substitution.